Today we're going to talk about understanding fractions. And if you've already seen me in class, which some of you may not, this is going to be the same lecture. I really enjoyed this part, and in class we have a lot of debate over this. So I want to put understanding fractions to you as something hopefully you'll understand. So here's how I do it in class. Pretend, if you will, we have two pizzas. They're the exact same size. So no matter whether they are or not, you got to understand they're the exact same size. I'm going to take those guys and I'm going to cut them. All right. So this guy I'm going to cut in half. I'm going to cut in half. Cut in half this way. Cut in half this way. All right. So I've cut that in so many pieces. Over here I'm going to do kind of the same thing, except for it's not going to be exactly the same. Okay, now some assumptions we have to do because I'm not the greatest artist or anything. This is exactly the same size pizza as this guy is. On this particular pizza, this piece here is exactly the same size as every single piece there, whether they're drawn to size or not. They are all the same size. Likewise, on this pizza to our right, every single piece is the same size. Okay, I don't really care what they look like. We just have to assume that. If we could do that, this lesson goes a little bit better. All right, so here's what I do. And if you know the community a little bit, we have a Pizza Hut and we have a mom and pop's place called Humble Pie. All right, so let's say you go to Pizza Hut and they cut the pizza this way. Well, when we're talking about fractions, you should know by now that the bottom number is the total possible. So if we count these pieces, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total pieces of pie. If we went to Humble Pie, let's say, they don't cut their pieces the same way. Let's say they cut them in pieces of 6. All right, so the bottom number, or denominator, still represents the total number possible that we could have of this pizza pie. Now, let's say we went to Pizza Hut on a Thursday night and we were a little bit hungry and we ate this many number of pieces. Well, if we count that many number of pizzas, we should be able to say 3. And 3 is our numerator. That's the total, that's the pieces, or the amount that we ate of the total of 8 pieces, or 1 pie. On Friday, we went to Humble Pie and we ate 2 pieces. All right, so here again, we ate 2 out of the total of the 6 pieces of pie. All right, so now what I want to know is which place did I eat more pizza? Okay, did I eat more pizza Thursday at Pizza Hut, or did I eat more pizza on Friday at the Humble Pie? Well, if I look at these numbers, you know, they're not the same. If I look at the pieces of pie, I can argue that yes, I ate more pieces at Pizza Hut than I did at Humble Pie, but I can also argue the fact that the pieces of pie are bigger at Humble Pie than they are at Pizza Hut. So it's really just an argument of he said, she said, and that's not exactly the case. Okay, and so what has to happen here is we have to decipher which one is exactly the amount, because if we go down to the ounce, probably somebody ate more in one place than the other, or we can actually decipher, are they equal? Okay, well, in order to do this, in order to compare, we have to have something in common. So we have to have what's called a common denominator. And our common denominator in this case is the least common multiple of both of these guys. And in this case, our least common multiple is 24. Okay, because 8 times 3 is 24, which makes it a multiple of 8. 6 times 24 is 24, which makes 6 which makes 24 a multiple of 6. I got that backwards, but sorry about that. We're going to go on. Okay, so anybody will tell you that what we do the bottom, we will also do the top. So if I took on the Pizza Hut pie, if I took the bottom times 3, I got to take the top times 3, and I get 9. On the Humble Pie, I took the bottom times 4, so I got to take the top times 4, and I get 8. And all of a sudden, it looks like I ate more at Pizza Hut than I did at Humble Pie, because now the common denominator is 24, but I ate 9 of those out of versus an 8 from Humble Pie. Well, if I think about this a little bit, And this is kind of the hard part to do, right? Because I took this 8 pieces and I made it times 3. Okay, so if I do that, it's actually like dividing these guys by 3. So there's 1. Now instead of 1 piece of pie, here I have 1, 2, 3. Instead of 1 piece of pie here, I have the 4th, the 5th, and the 6th piece. And we divide these guys, 7, 8, 9, and of course they're equal pieces now. My art is, me being an artist is not the greatest thing here. But if I do this and I divide these guys all up into equal portions, I will get back to 24 pieces. Whereas over here at Humble Pie, I had to take it times 4, so each piece actually gets broken down into 4 pieces now. So I have 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, if I broke these guys all up, right? If I broke them all up into individual pieces, boy, my artisanship's becoming bad. I still end up over here with 24 pieces. The same 24 pieces, and now I can compare these pies as equals, and I know exactly how much I ate, which 9 is bigger than 8, therefore I ate more at Pizza Hut. Now, yes, some of you may think, and this is going into a different chapter, well, I'll just change that into a decimal. Well, let's just examine that for a second. Not that we're going into decimals quite yet, but 3/8 as a decimal, when you divide, is that. Okay? And on a fraction, I can actually make it bigger or make it smaller. This guy's actually 1/3, which is this guy, right? 3/10 continuous. And 3/7 is bigger than 3, and the next digit here would be 3, obviously. So 7's bigger than 3. This guy would still be bigger. So as we can see, our decimals and our fractions better be exactly the same. So when we go to decimals, we're just going to have to remember that for every decimal value that ends or repeats, we have a fractional value to it. It doesn't really matter which one we use, decimals or fractions. So I hope that helps clear a few things up. We'll talk a little bit more about that in the upcoming sections, but this is always a good reference to come back to.